So in this video, we solve inclined plane problems without friction. A 2 kg box is put on a surface of an inclined plane at 27 degrees with the horizontal. The surface of the inclined plane is assumed to be frictionless. So, in part A, we need to draw a free body diagram of the box on the inclined plane and label all the forces acting on the box. The free body diagram and all the forces acting on the box. And in part B, we determine the acceleration of the box. Okay, so first we need to draw the problem. Okay, to understand the problem, we need to draw it at first. So that's the first step of solving a problem. So we draw it like this. As you see, the box is on the inclined plane, and the inclined plane is 27 degrees, and the box is 2 kilograms. This is the angle, 27 degrees. And the mass of the box is 2 kilograms as we know it. So it is 2 kilograms. So we draw it like this, and now we understand the problem, right? So this box is moving down the inclined plane. It's moving down the inclined plane. So we need to draw the free body diagram. That means we need to draw all the forces acting on the box. So we know downward there is the weight of the box, the weight, or we can say it mg, right? Weight is mass times acceleration due to gravity. So we know the weight, and it's directly down from the center of the box, and this weight has two components. This weight has two components, and the one component is along the inclined plane, and the one is perpendicular to the box. So we can draw the two components of this weight, and here the angle is the same. It is 27 degrees. The angle between this vertical line and the green line is 27 degrees. So, and there is another component of the weight, and it's along the direction of the inclined plane. So these two components, the first component, the first line is mg cos theta. So it is mg cos theta. The angle is still, as I told you, 27 degrees, and it will be mg cos theta, and the component of the weight along the inclined plane is mg sin theta. So we have all the forces here. As I told you, there is no friction here. So this is mg sin theta, and it's along the inclined plane. So it is the only force responsible for the motion of the box, because the box moves in that direction. It doesn't move in other direction. It moves in the direction of mg sin theta, right? All right, so there is a force which is normal force. We call it normal force. The normal force is opposite to the direction of mg cos theta. So we draw it all like this, and to draw the free body diagram, you need to isolate the body, that is a box, and we can draw it considering the box as a point, or we can draw it using the box itself, right? So let us draw the box first, and let us draw each and every force on the box. We will not draw the weight, but we will only draw the component of the weight, okay? So like this, we have force, and also in other direction we have another forces, right? So this is mg cos theta, and also there is mg sine theta, there is a normal force, there is no friction here. So these are the three forces acting on the box. So this is our free body diagram. We can consider the box to be a point, okay? And we can draw the forces, but now we took it as the box itself, so it's okay, okay? You can consider the box to be a point when you draw the free body diagram. So this is a free body diagram, and the force responsible for the motion of the box is only mg sine theta. Okay, so we draw the free body diagram like this. So we did A. Okay, what about B? So as I told you previously, the only force responsible for the motion of the body is mg sine theta, because the object moves only along the inclined plane. It doesn't move in any other direction. So we use Newton's second law to find the acceleration. So when we use the Newton's second law, we can consider the direction along the inclined plane as x and the perpendicular as y. So we can take this as x direction and we can consider that as y direction. So all the forces acting on the box, the summation of all the forces is equal to m times acceleration in the x direction. But we know there is no acceleration in the y direction, so we can call it a. So mg sine theta is equal to ma, and when we cancel the masses, acceleration will be g sine theta. So acceleration is equal to g sine theta, and we know g to be 10. Okay, approximately. For the matter of calculation, we can take it to be 10 meter per second square, and sine 27 degrees is 0.45. So 10 times 0.45 is 4.5 meter per second square. So the acceleration is 4.5 meter per second square. So we can find the acceleration like this if there is no friction and if there is no applied force when it moves by its own, okay? And secondly, we have another question. Draw a free body diagram and find the acceleration for the same problem, okay? Find the acceleration for the same problem if 20 Newton force is applied up the inclined plane. So the problem is like this, okay? Again, we need to draw diagram. So all the initial givens are the same, okay? The mass is 2 kilograms, but there is extra thing, and that is applied force 20 Newton. We applied 20 Newton force up the inclined plane, okay? So we are pulling the object upward 20 Newton. As we know it, there is mg sine theta down the inclined plane, and there is mg cos theta, and there is normal force, okay? So the forces will be 4. And as I told you, when we draw a free body diagram, we can consider the box to be a point-like object, okay? So let us take this point to be the box, and in this direction we have 20 Newton. This direction we have mg sine theta, mg cos theta here, and normal force. So we draw it like this. There is normal force, as I told you, the normal force, and also down there is mg cos theta. So, and there are other two forces. Here there is mg sine theta, and finally we have force applied, F is equals to 20 Newton. So this is our free body diagram. So we draw the free body diagram like this. FBD, or free body diagram. So we draw it like this, okay? We draw all the forces on the box. So this is all about the free body diagram, okay? it is about the forces on the object. So when we use Newton's second law to calculate the acceleration, so we have to know the forces responsible for the motion. So these two forces only are responsible for the motion of the box, because the box ultimately moves like this along the inclined plane direction, right? It doesn't move in any other direction. So summation of the forces in x direction is equals to m times a. Okay, so summation of the forces in y direction is 0. The acceleration is 0, right? So summation of the forces in x direction is equals to ma, because as I told you, the box moves along the x direction, along the inclined plane. So 20 Newton we have minus mg sine theta, which is equals to ma. So to get the acceleration, we just need to divide all sides by m. So we get 20 Newton minus mg sine theta divided by m. All right, so acceleration will be this, right? So we just need to put the numbers and we can get the answer right. So we have the acceleration, which is equals to 20 Newton minus the mass is 2 kilograms, 2 times the gravity is 10 times sine 27 degrees is 0.45 divided by the mass is 2 kilograms, so divided by 2 we can say. So and now we can get the answer right, because 20 Newton minus 2 times 10 is 20, 20 times 0.45 is 9. So we can do 20 Newton minus 9 Newton divided by 2. So we didn't use the units here for making it simple, okay? We didn't use the units here. So our answer would be 5.5 meters per second square. So this is the answer. The acceleration is 5.5 meter per second square. We can get it like this. We are right. In the next video, we will try to do inclined plane problems with friction and other things, okay?